In this question, we have a data table with clearly it's labeled as 3 different experiments. And the first experiment we see there's mass, net force, and time. So immediately you should be thinking F delta T is what we should be thinking here. And then we've got initial and final velocity, which we would recognize and think of as delta V. And so we could actually even calculate delta V. 6 minus 0 is 6, minus 3 is minus 6, and minus 9 minus a negative 3 is minus 6 as well. And if we do an F delta T, well, we can see this is 12, and this is 12, and this is 12. And if we take these delta V's and multiply it by the M's, we get 12, and minus 12, and minus 12. So that's if we do M delta V. So if we compare M delta V to F delta T, we can see that the numbers are approximately agreeing. So it's just something we're seeing up front, noticing the connections between and among the variables in the table. So the object is used 3 different experiments. The data is shown. How can they use it to determine between an object's change in momentum and the direction of the net force exerted on the object? Relationship between the object's change in momentum, delta P, and force direction. So the magnitude of the net force and the amount of time is multiplied to remain the same in each experiment. Well, that is true. Therefore, the net force changes the momentum of the object in the same direction for all the experiments. But we can see the change in momentum when we calculate it from M delta V is not. So something is not right in that question. That answer, that's that option. Observe the magnitude of the net force, the amount of time, and the mass of the object remain the same in each experiment. Okay. Therefore, the net force changes the momentum of the object in the same for all experiments. So again, we see the net force, it doesn't change them all the same. So it's not even a true statement. Next, we observe the direction of the velocity vectors for the initial and final velocities. If the final velocity is negative, the net force changes the momentum in the opposite direction of the motion. So if the final velocity is negative, so let's look at those. The net force changes the momentum in the opposite direction of the motion. So if you look at the motion, the original motion was 3 and minus 12. So indeed, that's opposite. But here we have minus 3 and minus 12. That's the same direction. So that's just not true statements. So it looks like we're at D all around. But let's check this out. Calculate the change in velocity of the object for each experiment, which we did. If the object decreases its speed or changes in direction, the net force changes the momentum in the opposite direction of the motion. So if the object decreases its speed, so in this case it increased its speed, here the speed remained the same before and after, although to go from 3 to minus 3 it must decrease then increase. Overall it remained the same. And in the third case, the velocity increased. Increases its speed, well, okay, and travels in the same direction, that's the last one. The net force changes the momentum in the same direction of motion. It's noticed the change is minus 12, and the initial velocity is minus 3. So we have a whole bunch of true statements in number 8. So in this question, we're not really seeking a great, tremendous physics insight or rule. We are just pulling apart all of the statements and the conclusions drawn from those statements and determining all of the false ones.